Hi everyone, welcome back to my channel. So today's video is not going to be about answering a question with a specific model, but I just want to share something that I used to be confused with. So I used to be confused with this concept for a while, so that every time I want to do something with it, I want to transform the dataset, I don't even know what I'm dealing with. Do I have a long data frame or a wide data frame? And so I always needed to consult an article or a video or a textbook that I used to read when I learned data science and just match the examples with my data frame. But now, after understanding the key difference between them, I can immediately identify the shape of my data frame. And so I hope this video can help you too if you're still having difficulty understanding this concept. In addition to learning the key difference between long and wide data frames, we will also try to transform long data frames to wide, wide to long in Python. Even though I'm demonstrating the transformation using Python, the basic principle is the same for all language and libraries. And one final note is that I'm going to explain this in the context of time series, even though, well, of course, this principle applies to all kinds of dataset. Okay, with that being said, let's study together. So before answering our question, we need to understand the anatomy of our data frame. This is sort of like a requirement. To be able to transform our dataset, we need to have these things: group ID, time ID, and value. Group ID has many synonyms like unique ID or entity. It's basically the series name. In other words, in our data frame, we need to have a group of time series or a group of data if you're dealing with a non-time series dataset. More concretely, group ID can be thought of as a key or some keys by which we group our data frame. The second one is time ID. Time ID is basically the timestamp, and usually every unique value in our group ID has the same time ID. So for example, we want to record the sales figures of 5 products from Monday to Sunday, then we would see Monday to Sunday 5 times. And then the last is the value. The value is, well, the time series itself. Now, in our data frame, we can have one for each, or we can have more. So perhaps we have 2 group IDs, and then 1 time ID and 1 value. Or we might have 1 group ID and time ID, but we have 3 values. That means we are dealing with multivariate time series. Okay, now that we understand the anatomy or like the roles that we need to have in our data frame, we can answer the question, what is the difference between long and wide? So in long data frames, the group ID and time IDs are put as columns. If we have more than 1 group ID or time ID or both, then we have to put all of them as columns to be able to identify them as long data frames. In wide data frames, though, some of them are put as columns while the others as rows. Let's say that we have the time ID as columns, and then the unique values of the group ID are put as the names of our columns. That was so bad. The handwriting is very untidy, so yeah. It's not much tidier, but anyway. We can also have the group ID as columns and the unique values in the time ID as our names of the columns. Now, these 2 configurations are true if we have 1 group ID and 1 time ID. But what about if we have more than 1 group ID or time ID? It's still the same. We just have several IDs as our columns. So we might have group 1 and group 2 as our columns, and then for the names of the columns, we use 2, like 2 IDs, maybe time 1 and time 2 here. Time 2 would be below time 1, if time 2 is in in higher frequency than time 1. For example, if time 1 is yearly and time 2 is monthly, then we can put it out like this. Okay, now let's see some examples. Maybe you want to pause the video first and try to guess which format this data frame has. Okay, so this data frame is a weekly sales transaction for 800 products, but in this particular screenshot, I only show you 400 products. And yeah, it's a weekly sales. And so we have the product code as columns, and W, if you look at the name of the rest of the columns here, it's week. It denotes the week. So week 0, week 1 until week 7. So it's the time ID. So the unique values of the time ID are put as columns, and the product code stands as the group ID. Because the IDs are spread like this, that means we have a wide shape. Okay, now the next example is the CPI for the United States from 1913 to 1930. And it's laid out like this. We have the column year, and then for the rest of the columns we have month from January to December. So we can think of the year column as our group ID, while the January to December columns as time ID. The group ID and the time ID are again spread it out like this. Therefore, this is a wide data frame. Okay, next example. This data is taken from Kaggle Tabular Playground series, January 2022. And it's about the sales again. So the background is that Kaggle has merchandise stores in several countries, in 3 countries if I remember correctly. In several countries, in several stores, and each store has several products. And then this is our time series, the num sold, the number of the item sold every day. If you look at the date, this is a daily data set, a daily time series, sorry. As we can see here, we have multiple group IDs, 3 to be exact, the country, store, and product. And then we have one time ID and one value, which is the num sold. Because all of the IDs, the group IDs and the time ID are put as columns, this is a long data frame. Well, looking at this data frame reminds me of another difference between long and wide data frame, but this is not a key difference. I mean, there's an exception to this one, yeah, but I think it's still worth mentioning. So notice that in this data frame, a long data frame like this one, we can see clearly the name of our time series, which is num_sold. And that's not surprising because the other IDs are also put as columns, right? So basically we have our time series as columns, and therefore we need a column name. But in wide data frames like CPI here and the weekly sales, we don't see any name for the time series. So just by looking at the data frame, we don't know what we're looking at unless we have extra information. But there's an exception to that, I think, because we can only see this difference if we have only one time series. In other words, univariate time series. If we have more than one, if we have 2 or 3, I think we can still configure it somehow so that we can see the name of the time series. So I think, yeah, the first thing that you need to look at is how the time ID and group IDs are laid out. This particular screenshot shows you the data set sorted by store and product. Okay, so for a specific country in Finland, store Kaggle Mart and Kaggle, the product is Kaggle Mug, we cannot get a time series right away. So this is January 1st, and then this, where? Yeah, January 2nd would be out of this screenshot. So to get a better idea of our time series, I took a screenshot of this dataset sorted by country. There we can see the time series here. Let's look at our last example. So this screenshot is taken from COT, Commitment of Trade report, but I have just taken several columns for this particular example. In this particular example, we have more than one value now, starting from column C to column F, and then column B, report date as month, day, year, is our time ID. While for column A, I think it's quite clear that this is the group ID. We would have lots and lots of market and exchange names. And if you take a look at the report date year, it's a weekly time series. The group ID and the time ID are put as columns, so we have a long data frame. Okay, now let's transform these data frames in Python. Okay, now let's try to transform our data frames. The first is the CPI data frame. It's a wide format. Well, you know what? Let's run this. So this is the CPI data that we saw earlier. The year is our group ID, and January from December are our time ID. So the real data set spans over 112 years, from 1913 to 2024. And then of course we have 12 months. So the unique values in our time ID is 12. Now we want to transform it. To do that, we use melt function from Pandas. And the important thing to look at when we want to transform from wide to long is which columns. We need to look at which columns we want to take as our time ID in this case. Or if you have the unique value of group IDs broken into names of columns, then you need to know which unique values that you want to take as your group ID. Okay, so in melt function, first of all, we need to pass the dataset, which is CPI. I named it as CPI, and then the ID vars is the ID that stands as column. In this case, we have the column year. This column plays a role as the group ID. Var name is the time ID name. So after moving the January to December columns here, we move it to a column, then we have to name it, right? And what's the name of that? I name it as month. And then lastly, this is optional actually, the value name. Again, because in long data frames, we can see the value name, value array name explicitly. We have the option to name it, and I name it as CPI. Okay, let's run it. So this is our transformed dataset. Remember, this is our wide format, but after pivoting, we have long format. Year, the year is the group ID, and the month, which is the time ID. So now the values of month, January to December, is repeated. January, February, down to December, and then repeated again, January, February, down to December, and so on. And this is our value, the CPI. I use this to check my work. So the total rows, because we are in long format, it should be the total rows in the original dataset, which is the total year, which is 112 times 12. Because now each row has a combination of year and month. And yeah, certainly it's true. So it verifies that it is a long format. Okay, now let's move on to our next example. The next example would be the weekly sales transaction. And actually I did clustering with that dataset in the previous video. You can check that out. So the real dataset or the original dataset is in white format. The group ID is the product code and the time ID is the week. Our group ID has already laid out as a column, but the time ID is still in rows, so we need to move it into a column and then name it. So the ID vars again is the product code. That's our group ID or any ID that already stands as a column. And then the var name is called week. Oh, sorry. Yeah, it's the week. So yeah, I will name it as week. And then the value name would be quantity. So this is the quantity of products that is sold each week. Okay, so this is our data after pivoting. Again, we have 811 products. So the rows of our original data frame is 811. And then we have 52 weeks. So the total rows after we pivot our data frame would be 811 times 52. And this is the snippet of our long data frame. The week, which is the time ID, is now put as a column, and the product code stays the same. And the value in the original data frame, it's laid out horizontally. So for product 1, the sales are put as rows, but now it's put as column. So it will be a stack of time series. Actually, looking at this snippet here, it makes me realize that this data frame is still sorted based on week. And I think that's the default output from melt function. So the melt function will sort the output, the new data frame, based on the var name. But this is kind of easy to work around. You can just sort it again using product code. Okay, now the next example is the long format, the COT report. So the original shape is like this. This is not a complete COT report. Okay, so in this particular example, we have 87 rows and 4 columns. So yeah, this is not the same as the screenshot that we saw earlier. In the screenshot we saw earlier, we have 4 time series, but in this case we have only 2 time series, and then 1 group ID, which is the market and exchange names, and then the time ID is the report date. Here in the head of our data frame, we cannot see the report date because the names of each columns are quite long. Now we have a long format, so the group ID and the time ID are put as columns, but now we want to transform it into a wide data frame. To do that, we have to decide which column or which ID that we want to break into the names of our columns. And the function is now not melt anymore, of course. The function is pivot. It's a method from the data frame. Okay, so we're using pivot columns. I'm using my group ID as our columns now. Okay, so market, exchange, and names. We won't see the. We will see like Canadian dollar, Chicago Mercantile Exchange as the name of our column. And then the index, this is the ID that will stand as a column, and I will use report date. I'll show you the Excel file of the transformed dataset, but for now, just look at the difference between the original shape and the pivoted shape. The explanation is that we use the group ID as our names of columns, so we have 67 unique values in the group ID, and we have 2 time series. Therefore, we have 67 times 2 columns, which is 134. In the pivot function, we use report date as our index. So because of that, the pivoted data frame doesn't count report date as a column. It's counted as an index. So therefore, when we calculate the total of columns, it's still true that we have 67 times 2 columns. And since our time ID stands as a column, we have 32 unique dates. And after pivoting our data frame, we have 32 rows. So even if we don't look at our full data or our transformed data set, we might be able to confirm that we have pivoted the right way. Okay, let's move on to our last example, which is the Kaggle merchandise store. The original shape is in long format, again, with 3 group IDs and 1 time ID. We have 3 countries. Each country has 2 stores and each store has 6 products. Oh, sorry, I mean 3 products. So in combination, if we want to calculate all the combinations, we would have 3 times 2 times 2, which is 12. And for the time ID, we have 1460 days. The time series ranges over 3 years. And to pivot that, to transform that into a wide format, we still use the pivot function. Okay, but now we have to decide which ID stands as columns, because we have more than one group ID. Okay, in this case, I just decided to take country and store as our columns, and then the index are product and date. So the ID that will stand as columns would be product and date, whereas the country and store, so the unique values of countries and the stores, would be broken into names of the columns. Okay, so this is the original data frame again. Now, after pivoting, it looks like this. Okay, so the columns here, product and date. Okay, it's stating that this is the num sold. And then, and for the rows, we have 2 indexes, country and the store. So in Finland, we have Kaggle Mart and Kaggle Rama. And then in another country, we have another Kaggle Mart and Kaggle Rama, like that. Okay, so that's it for today's video. In today's video, we have learned the key difference to identify which data frame we have. And then we also have tried to transform it from long to wide and wide to long in Python. I hope you find this video helpful. The code would be uploaded on my GitHub. Don't forget to subscribe, share this video, and comment and give it a like. And I'll see you next time. Bye-bye.